Today we're going to talk about integer and rational exponent laws. You've actually seen these before through your in-class activity, but today I want to talk about them using proper terminology and to refresh your memory. So when I talk about integer exponent laws, the word integer reminds me of the number line, where I'll have 0, 1, 2, 3, -1, -2, and -3. The integer exponent laws talk about what happens when the exponents are different integer values. So these are whole numbers that can go from the negative to the positive end. So if you recall, any number like 5 to the power of 0 will always give me 1. Every power starts at 1. Then when we go into the positive side of the integer, we have, for the exponent, we have 5 to the power of 1, which means 1 times only 1 of 5. So our final answer is 5. When I have now the integer exponent of 2, is that telling me that I take the 1, multiply by 2 5s. So I would get 25. And again, the exponent 3 would tell me to multiply my 1 by 3 of the number 5. So I'd have 125. Now that's the positive integer side. You've seen this before since grade 9, what you need to do when you have a positive integer as the exponent. What's new this year is when you have the negative integer exponents, like -1, -2, and -3. So when we move from 0 to a positive, we are multiplying it by the number of the base. So 1 of the 5, 2 of the 5, and 3 of the 5. Reversely, when we go in the negative direction of the integer line, we're going to do the opposite of multiplying, which is divide. So now, we always start at 1, but instead of multiplying by 5, like we did with 5 to the power of 1, when I have 5 to the power of -1, I'm going to divide by 5, which will give me 1/5. When I do the exponent of -2, the -2 tells me to divide by 2 of the 5. If you were to expand this out, you'd have 1 over 5 divided by another 5. If you recall fractions, when I divide, I multiply by the reciprocal. So 5 becomes 1 over 5. Multiplying these two fractions together, I get 1 over 25. And again, for my 5 to the power of -3, I have 1 divided by 5, divided by 5, divided by a 5, which will give me 1 over 5 times a 1 over 5 times a 1 over 5 when I apply the fraction rules like I did in 5 to the power of -2. So I would have 1 over 125. So this is what's really going on with integer exponent laws. The quick method, the shortcut you can think of, is that when I see a negative in my exponent, it means that I have to take my base being 5, and I flip it, or take the reciprocal. 5, or any number, is always over 1. So the negative would tell me to flip it, or take the reciprocal, which is 1 over 5. If I had the example of 2/3 to the power of -1, this -1 would tell me to take the reciprocal of 2/3, which, flipping the fraction, would be 3 over 2. And that would be to the power of 1, which is just 3 over 2. Okay? And if I had 2 over 3 to the power of -2, that would mean I would flip it, 3 over 2, and I would take the whole fraction and multiply it by itself twice. Or take 1 and divide it by 2/3, divide by 2/3, which means I flip it and multiply it twice. So then I actually have to apply my power to each, the numerator and the denominator. So 3 to the power of 2 would be 9, 2 to the power of 2 would be